and we're solving the pleasant fractions problem.
Go math!
So, to be a pleasant fraction, a fraction must be greater than 0.
The denominator of the fraction is 4 more than the numerator.
And subtracting 1 from both the numerator and denominator of the fraction forms a new fraction that is at least as large as the reciprocal of the numerator of the original fraction.
Yay!
Now we want to know if there's one with a smaller numerator than any other, if there's one with a larger numerator than any other, and for all pleasant fractions for which the numerator is positive, is there one with a smaller numerator than any other? Okay, so step 1, we have that x is the numerator and y is the denominator. Now, according to rule number 1,
x over y is greater than 0.
And rule number 2,
y equals x plus 4.
So from that, we can conclude that x divided by x plus 4 is greater than 0. Now, step 2 is satisfying those two rules. So for x over x plus 4 is greater than 0, there are two possible cases. In the first case,
x is greater than 0 and x plus 4 is greater than 0.
This is when the numerator and denominator are both positive. In case 2,
x is less than 0 and x plus 4 is less than 0.
This is when the numerator and denominator are both negative, which a negative divided by a negative makes a positive number. Now, in case 1, when they are both positive, you have that the numerator is x is greater than 0 and the denominator x plus 4 is greater than 0. X plus 4 is greater than 0 simplifies to
x is greater than negative 4.
So x is greater than 0 and x is greater than negative 4 are combined to just x is greater than 0, as shown on the number line. Case 2, x is less than 0 and x plus 4 is less than 0. X plus 4 is less than 0 can be simplified to
x is less than negative 4.
So x is less than 0 and x is less than negative 4 can be combined to be
x is less than negative 4,
as shown on the number line. So, to satisfy Rule 1 and Rule 2, x is greater than 0 or
x is less than negative 4,
as shown on the number line. So, Step 3 works with satisfying Rule 3, which, if you have forgotten, is that subtracting 1 from both the numerator and denominator of the fraction forms a new fraction that is at least as large as the reciprocal of the numerator of the original fraction. So, if you have x over x plus 4 as your original, you're subtracting 1 from each side, it goes to x minus 1 over x plus 4 parentheses minus 1 is greater than or equal to 1 over x, because the reciprocal of the numerator of the original fraction. And that simplifies to
x minus 1 over x plus 3 is greater than or equal to 1 over x.
So x minus 1 over x plus 3 is greater than or equal to 1 over x means that there's a domain restriction. X doesn't equal negative 3 or 0, because if either one of those were true, then the fraction would be undefined. Now that you have x minus 1 over x plus 3 is greater or equal to 1 over x, we can subtract 1 over x from the right side. So we have x minus 1 divided by x plus 3 minus 1 divided by x is greater than or equal to 0. Now we want to find a common denominator.
Common denominator!
But we do that by
multiplying x minus 1 over x plus 3 by x over x, and multiplying negative 1 over x by x plus 3 over x plus 3.
So now our inequality is x squared minus x minus 3 divided by x times x plus 3 is greater or equal to 0. Next, we can simplify the numerator to be x squared minus 2x minus 3 divided by x times x plus 3 is greater than or equal to 0. That numerator factored is x plus 1 times x minus 3 divided by x times x plus 3 is greater than or equal to 0. Now, step 4 is solving that last inequality that we just stated. So either x plus 1 times x minus 3 divided by x times x plus 3 can be equal to 0 or greater than 0. So for the case where it's only equal to 0, we know that the fraction's numerator must equal 0 to make the whole thing 0. So x plus 1 must equal 0 or x minus 3 equals 0. Therefore, x equals negative 1 or x equals 3. Next, we have x plus 1 times x minus 3 divided by x plus 3 is greater than 0. But keep in mind that our domain restrictions are that x doesn't equal negative 3 or 0. And from our solution from where it's equal to 0, we can make a number line that has negative 3, negative 1, 0, and 3. And use that to make our cases. Case 1.
Case 1 is that x is less than negative 3.
In that case, the x plus 1 in the numerator would become negative, the x minus 3 would become
negative,
and the x in the denominator by itself would become
negative,
and the x plus 3 in the denominator would become
negative,
and it's all greater than 0. And a negative times a negative is a positive, and since it's like that in the numerator and denominator, then a positive divided by a positive is greater than 0. So x is less than 3 is a solution for this case. Case 2, negative 3 is less than x is less than negative 1. In this case, x plus 1 in the numerator is
negative,
x minus 3 is
negative,
and in the denominator, x by itself is
negative,
but x plus 3 is
positive.
Now a negative times a negative is a positive, divided by a negative times a positive, which is negative, is a positive divided by a negative, which is greater than 0, so negative 3 is less than x is less than negative 1 is not a solution for this case. Case number 3. Negative 1 is less than x is less than 0. In this case, x plus 1 in the numerator is
Positive.
X minus 3 in the numerator is
Negative.
X by itself in the denominator is
Negative.
and X plus 3 in the denominator is
Positive.
Now, a positive times a negative is a negative, and a positive times a negative again is a negative, and a negative divided by a negative is a positive, so it is greater than 0. So negative 1 is less than X is less than 0 is a solution.
Yay.
Case 4. 0 is less than X is less than 3. In this case, X plus 1 in the numerator is
Positive.
X minus 3 is
Negative.
X by itself in the denominator is
Positive.
and X plus 3 is,
Positive.
and that negative times a positive is a negative in the numerator, and a positive times a positive is a positive in the denominator, and the negative divided by a positive is not greater than 0. So 0 is less than X is less than 3 is not a solution for this case.
Nope.
Case 5, the final case. X is greater than 3. In this case, X plus 1 in the numerator is
Positive.
X minus 3 is
Positive.
in the denominator, X by itself is
Positive.
and X plus 3 is
Positive.
so a positive divided by a positive is greater than 0. So X is greater than 3 is a solution.
Yay.
Step 5, we summarize.
Yay.
Rule 1 and Rule 2 solutions turn out to be X is less than negative 4 or X is greater than 0 as shown in the number line. The solutions is X is less than negative 3 or between negative 1 and 0 or greater than or equal to 3. So, all solutions combined, as shown in this number line, is X is less than negative 4, or X is greater than or equal to 3. Final solutions are X is less than negative 4, or X is greater than 3, as shown in the number line. So, to solve our first question, among all pleasant fractions, is there one with a smaller numerator than any other? If there is one, what is its value? There is not one, because there is an infinite number of values less than negative 4. Our second question is,
among all pleasant fractions, is there one with a larger numerator than any other? If there is one, what is its value?
there is not one, because there are an infinite number of values greater than 3. Finally, among all pleasant fractions for which the numerator is positive, is there one with a smaller numerator than any other? If there is one, what is its value? Going back to trying to satisfy Rule 3, when x plus 1 times x minus 3 divided by x times x plus 3 is equal to 0, then x equals negative 1 or 3. So 3 is our smallest possible numerator. And 4 plus 3, which is what we must do to get the denominator of the pleasant fraction, is 7. So, a positive numerator where it's smaller than any other must be 3/7 as the fraction. These are our final answers. Thank you.
Thanks.
This is my sister.
Hi.
Goodbye.